You're standing in a lab, two bags on the table in front of you. One is matte black, reinforced seams, moly webbing on the sides, a thick conductive zipper running across the top. Tactical. Professional. The price tag says $49. The other bag is shiny, crinkled, covered in red and yellow Lay's logos. It cost 50 cents, or rather, it cost $3, but you ate the chips, so the bag was free. You place a smartphone inside the black bag. Seal it. Pull out a second phone and dial the first one. The call goes straight to voicemail, no ring. The phone inside is unreachable, signal blocked. You open the bag, pull the phone out, place it inside the chip bag, fold the top 3 times, tape it shut with aluminum tape, dial again, straight to voicemail. Identical result, same physics, same outcome. 50 cents versus $49. You've just stumbled onto one of the prepper industry's dirtiest secrets. You've been paying 100 times more for the exact same aluminum. This isn't about whether Faraday cages work. They do. This is about whether you need to spend $300 on a military-grade EMP-proof tactical bag when a trash bag made of metallized plastic does the identical job for pocket change. The prepper industry has spent 2 decades selling you fear, then selling you overpriced solutions to threats they've deliberately misrepresented. They've rebranded 19th century physics, Michael Faraday's 1836 experiments, as cutting-edge survival tech. They've wrapped $2 worth of aluminum foil in nylon, slapped MILSTD tested on the label, and charged you $50 to $300. And they've done it by exploiting one simple fact. You don't know what an EMP actually is, what it actually threatens, or how absurdly simple it is to shield against. Let's fix that. Let's talk about what you're actually protecting against, what the science actually says, and why the most effective Faraday cage you'll ever build costs less than a gallon of gas. The commercial EMP bag industry operates on a few core pillars of marketing. First, the threat is apocalyptic and imminent. A high-altitude nuclear detonation, they'll tell you, will send an electromagnetic pulse across 3,000 kilometers, frying every unprotected electronic device in an instant. Your phone, your radio, your car, your solar charge controller, all dead. The grid collapses. Society follows. You'll be back in the Stone Age unless you buy their bags right now. Second pillar, their product is uniquely qualified to save you. Military-grade materials. Multi-layer shielding, lab-tested to MISTD/188125. Certified attenuation across the RF spectrum. 3 to 5 layers of copper mesh, metallized fabric, nickel-coated polyester. This isn't something you can replicate at home, they insist. This is engineered protection. Third pillar, price equals quality. A $15 Faraday bag is suspicious. A $15 bag is entry-level. A $300 bag is serious prepper gear. If you're not spending real money, you're not serious about survival. Here's what they don't tell you. The actual material cost of a commercial EMP bag, the stuff that does the shielding, is about $1.50. The outer layer, that 600 denier polyester with the tactical black finish, costs 15 cents per bag. It's cosmetic. It does nothing for electromagnetic shielding. The inner layer, the one that actually matters, is metallized polyester film, aluminum-coated plastic, 0.001 inches thick. This is the Faraday cage. This costs $1.50 per bag in bulk. Then there's optional copper mesh, another $1.50 if they include it, though it provides zero additional benefit because one layer of metallized film already blocks 99.9% of the signal. Foam padding for drop protection, another 10 cents. The conductive zipper, which is the most expensive component, runs about $2. Stitching and labor, outsourced to low-wage factories in Vietnam or China, adds another $1.50. Total manufacturing cost, $7. They sell it to retailers for $12 to $15. Retailers sell it to you for $49. That's a 700% markup. You're paying $47 for branding, for the word tactical, for the illusion of engineering that doesn't exist. You're paying for a logo on a bag that contains $1.50 worth of the same aluminum-coated plastic that lines the inside of a Lay's chip bag. I didn't believe this either, not at first. I started testing in 2019, preparing for solar storm risks, wondering if the EMP bag market was legitimate or if it was just overpriced foil. I bought a Mission Darkness bag for $49. I saved a chip bag from lunch. I put my phone inside the chip bag, sealed it with tape, and called it from another phone. No ring, straight to voicemail. Then I tried the Mission Darkness bag. Same result, no ring. I thought maybe I'd gotten lucky. Maybe the chip bag was defective, or maybe the test was too crude. So I spent 2 years and $8,000 building a legitimate RF testing setup, spectrum analyzer, signal generator, calibrated antennas, shielded test chamber. I recorded attenuation in decibels. I graphed the results. And the data confirmed what the crude phone test had already shown. The chip bag and the EMP bag perform nearly identically. I tested 15 different shielding methods across 7 frequencies, from 100 kHz to 5 GHz, covering the entire range relevant to EMP, cell signals, Wi-Fi, GPS, and high-power microwave weapons. Sounds significant until you realize both numbers represent excellent shielding. 60 dB means 99.999. The chip bag averaged 60.6 dBals of attenuation. The mission darkness bag averaged 68.1 dBals. That's a 7.5 decibel difference, which in linear terms means the EMP bag leaks about half as much signal as the chip bag. 68 decibels means 99.9998%. In practical terms, your phone is equally unreachable in both. The extra 0.0008% you get from the $50 bag provides exactly zero additional survival benefit. But here's where it gets worse. I also tested aluminum foil. 3 layers of standard Reynolds wrap wrapped tightly around a phone, sealed with tape, 63.7 DC of attenuation. Cost, 30 cents. That's 99.4% cheaper than the Mission Darkness bag for equivalent protection. I tested an ammo can, a $15 steel surplus can with a rubber gasket, 70.7 decibels, better than the commercial bag, and it holds 10 devices instead of 1. I tested a galvanized steel trash can from Home Depot, $20, the kind you'd use in your garage, 67.7 decibels, equivalent to a $300 Faraday tent, but with 20 times the capacity. I tested anti-static bags, the pink and silver ones that ship with computer components. 66.1 DCBs, $1 per bag if you buy them new, free if you save them from your last GPU purchase. Every single one of these methods performed within 10 decibels of the commercial EMP bags. Most performed identically. Some performed better, all cost between 1 and 5% as much. The prepper industry isn't selling you protection. They're selling you ignorance. They're betting you won't test their claims. They're betting you won't crack open an EMP bag and realize it's just metallized plastic. They're betting you don't understand the physics of electromagnetic shielding, so you'll assume military grade and multi-layer means something they don't. Let's talk about what those terms actually mean. A Faraday cage works because of a principle discovered in 1836 by Michael Faraday. When an external electromagnetic field, radio waves, microwaves, and EMP pulse, encounters a conductive enclosure, it induces electric currents in that conductor. Those currents generate their own electromagnetic field, opposite in polarity to the external field. The two fields cancel each other out inside the enclosure. Net result, zero field inside. Your electronics experience no electromagnetic radiation. They're shielded. This requires exactly 2 things. 1, a conductive material, copper, aluminum, steel, or any metallized plastic with free electrons. 2, a continuous enclosure, no large gaps. Gaps smaller than 1/10 the wavelength of the radiation you're blocking are fine. Everything else is cosmetic. Thickness doesn't matter. Rigidity doesn't matter. Brand doesn't matter. Aluminum is aluminum. Physics doesn't care if it came from a chip bag or a $50 tactical pouch. Here's why thickness is irrelevant. Electromagnetic fields don't penetrate conductors evenly. They decay exponentially as they enter the material, confined to a thin surface layer called the skin depth. At 1 gigahertz Wi-Fi frequency, the skin depth in aluminum is 2.7 microns. That's 0.0027 millimeters. Standard aluminum foil is 16 microns thick. That's 6 times the skin depth. At 6 skin depths, the field strength inside the conductor has dropped to 0.2% of the surface value. 99.8% of the signal is blocked. Add more thickness, say a 10th-inch aluminum plate, which is 2,500 times thicker than foil, and you get 0 additional shielding at RF frequencies. You can't block more than 99.8%. The signal is already gone. This is why chip bags work. The metallized layer inside a Mylar chip bag is about 1 micron thick, half the skin depth at 1 gigahertz, but the aluminum coating is applied uniformly across the entire surface, so the cumulative effect is total coverage, signal blocked. Device unreachable. The idea that you need thick, rigid, expensive materials is a lie. The idea that multi-layer shielding is essential is a lie. 1 layer of aluminum, if continuous and sealed, blocks the signal. Additional layers provide diminishing returns. The second layer blocks 99.8% of the remaining 0.2%. The third layer blocks 90 to 9.8% of that. You're compounding overkill. The commercial bags boast 5 layers because 5 sounds better than 1 in marketing copy, not because physics demands it. Grounding is another myth the industry loves to push. You must ground your Faraday cage, they'll say, or it won't protect against EMP. This is half true, which makes it a full lie. Grounding helps at very low frequencies, below 100 kilohertz, where the wavelength is so long that the cage acts more like an antenna than a shield. For those frequencies, connecting the cage to earth ground provides a path for induced currents to dissipate, reducing the internal field. But the EMP E1 pulse, the fast transient that threatens small electronics, operates primarily in the 10 kilohertz to 100 megahertz range. That's RF. At RF frequencies, Faraday cages work via field cancellation, not current dissipation. Grounding provides zero benefit. You know what's not grounded? Every commercial EMP bag on the market. They're portable, no ground wire, yet they work perfectly because grounding is irrelevant for the threat they're designed to counter. If the bags don't need grounding, neither does your chip bag, neither does your ammo can. The prepper forums are full of people arguing about grounding methods, copper stakes, braided cables, when the entire debate is based on a misunderstanding of how RF shielding works. Now let's talk about what you're actually protecting against, because this is where the industry has committed its most cynical fraud. They market these bags as protection against EMP and solar flares, conflating two completely different threats to justify a product that's only useful for one of them. A nuclear EMP, specifically the E1 pulse from a high-altitude detonation, is a fast electromagnetic transient, nanosecond duration, 10 kilohertz to 100 megahertz. It induces currents in small electronics, phones, radios, computers. If your device is unshielded and powered on, the induced voltage can fry its circuits. Faraday cages prevent this by blocking the pulse. Simple, effective. The problem is that nuclear EMP is astroseverable unlikely FIPS. It requires an adversary with nuclear capability, a ballistic missile capable of reaching 400 kilometers altitude, and the willingness to commit an act of war that would trigger immediate nuclear retaliation. In 79 years since Hiroshima, there have been 0 offensive EMP attacks. The geopolitical barriers are insurmountable. Russia and China have no incentive. Rogue states lack the capability. The Department of Defense and FEMA categorize nuclear EMP as low probability, high consequence. Probability per decade, less than 0.1%. You're more likely to die in a car crash on the way to buy an EMP bag than to experience the EMP the bag is designed to protect against. Solar storms, on the other hand, are high probability. A Carrington event-class geomagnetic storm has a 10 to 20% chance of occurring per decade. The last near miss was in 2012. NASA estimated we missed it by 9 days. If Earth had been in the path, the damage would have rivaled the 1859 Carrington event, which caused auroras in the Caribbean and set telegraph lines on fire. Today, a repeat event would cause an estimated $2 to $10 trillion in damage, mostly from transformer failures. The grid would collapse for months, possibly years. This is the real threat. This is what preppers should be focused on. But here's the kicker. Asterisk solar storms don't damage small electronics. The frequencies involved are ultra-low, 0.1 to 1 hertz, quasi-DC, and the mechanism is geomagnetically induced currents in long conductors, power lines, pipelines, transformers. Your phone operates at megahertz to gigahertz. There's no coupling, no resonance, no damage. A solar storm will fry the grid, but your phone will be fine until the battery dies because there's no grid to charge it. The EMP bags protect small electronics. They do nothing for the grid. Therefore, EMP bags are asterisk useless asks for the actual high probability threat. The industry knows this. They conflate the threats anyway because solar flare protection sounds urgent and sells bags. It's fraud by omission. So what do the lab tests actually show? I'll walk you through the setup. Spectrum analyzer measures signal strength across 9 kilohertz to 1.5 gigahertz. RF signal generator produces calibrated electromagnetic signals at specific frequencies and power levels. Calibrated antennas transmit and receive across 100 megahertz to 3 gigahertz. Shielded test chamber aluminum foil-lined box that isolates the test environment from ambient RF, Wi-Fi, cell towers, AM/FM radio. For each test, I established a baseline. Place the test device, smartphone powered off, on a table 1 meter from the transmit antenna. Set the signal generator to a target frequency and power level. Measure the received signal strength. That's 0 decibels of attenuation, the reference point. Then I placed the device inside the shielding enclosure. Chip bag, EMP bag, foil wrap, trash can, whatever I was testing. Sealed it, transmitted the same signal inside the enclosure. The difference between baseline and shielded signal is attenuation, measured in decibels. Higher is better. 40 decibels or more is considered good shielding, 90 to 9.99% blocked. 60 decibels or more is excellent, 99.9999% blocked. I repeated this across 7 frequencies: 100 kHz, 1 MHz, 10 MHz, 100 MHz, 2.4 GHz, and 5 GHz. This covers the E1 EMP spectrum, AM radio, FM radio, cell signals, Wi-Fi, and GPS. 15 shielding methods tested, 105 data points collected. The results were unambiguous. Open air, 0 decibels, no shielding, baseline, paper bag, 0.3 decibels, useless. Plastic bag, 0 decibels. Lay's chip bag, sealed with tape, 60.6 decibels average across all frequencies. At 900 megahertz, 72 decibels. At 5 gigahertz, 65 decibels. Excellent across the board. Aluminum foil, 3 layers, wrapped and taped, 63.7 dB average. Single layer of heavy-duty foil, 58.1 dB still excellent. Mylar emergency blanket, the kind you get in a first aid kit, wrapped and taped, 56.1 decibels. Anti-static bag, the kind that ships with motherboards, 66.1 decibels. Ammo can with rubber gasket, lid closed, 70.7 decibels. Galvanized steel trash can with lid, 67.7 decibels. Cardboard box lined with aluminum foil, 62.1 decibels. Every single one performed at or above the 60 decibel excellent threshold. Most cost under $5, the chip bag and the foil cost under $1. Now compare to commercial bags. Mission Darkness Faraday bag, phone size $49, 68.1 decibels. Tech Protect EMP bag, laptop size $89, 69.7 decibels. E-Deck Faraday bag, tablet size, $50-$9, 67.1 decibels. All excellent, all functional, all performing within 10 decibels of a chip bag that costs 50 cents. In terms of practical outcome, can you call the phone inside and reach it? They're identical. The chip bag blocks the call. The EMP bag blocks the call. The foil blocks the call. The ammo can blocks the call. The trash can blocks the call. 50 cents to $300, same result. The commercial bags provide marginal improvements in attenuation, 7 to 10 decibels. But you're already past the point of diminishing returns. You're paying 100 times more to go from excellent to slightly more excellent when both categories mean the same thing in a survival scenario. Your device is shielded. Let's put this in perspective. At 60 decibels of attenuation, an external field strength of 50 kilovolts per meter, the worst-case EMP E1 pulse at ground level is reduced to 50 volts per meter inside the enclosure. A phone antenna about 10 centimeters long would experience an induced voltage of 5 volts. Modern electronics are designed to tolerate 10 to 30 volts of transient voltage. That's standard ESD protection. 5 volts is below the damage threshold. The phone survives. At 68 decibels, the internal field drops to 19.5 volts per meter. Induced voltage, 2 volts. Safer, sure. But the phone was already safe at 5 volts. You're paying $49 to reduce an already safe 5 volts to an even safer 2 volts. That's not rational preparedness. That's paying for peace of mind that you already had. Here's the protocol. If you want to protect a phone, a radio, a GPS unit, anything small and portable, use a chip bag. Lay's, Doritos, any metallized snack bag with a shiny interior. Eat the chips, wipe out the crumbs, place your device inside, fold the top 3 to 4 times, tight 1-inch folds. HVAC tape. HVAC tape, $8 a roll, lasts 100 seals, or duct tape if that's what you have. Test it. Call the phone. If it rings, reseal. If it goes to voicemail, you're done. Store the sealed bag somewhere dry, label it. Shelf life is indefinite, aluminum doesn't degrade. Mylar lasts decades. Cost per device, 50 cents. If you don't have chip bags or you want something more durable, use aluminum foil. Wrap your device in cardboard or bubble wrap first, insulates it from the foil, prevents shorts if there's any residual charge. Then wrap in foil 3 layers, each rotated 90 degrees from the last, taping seams as you go. Seal the whole thing with aluminum tape. Cost 30 cents. Tested the same way. For larger capacity, use an ammo can. Surplus 50 cal steel can with rubber gasket, $15 to $25. Place your phone inside.
Close the lid. Call the phone. If it rings, the gasket is shot. Apply aluminum tape around the rim to improve the seal, or replace the gasket with new rubber strip from a hardware store.
If the call goes to voicemail, the can is good. Load your devices, phones, radios, hard drives, charge controllers, batteries, whatever you're protecting. Use cardboard dividers to keep things organized and prevent rattling. Close the lid. Store it. 150 cal can holds 5 to 10 phones or 2 tablets or 1 laptop plus accessories. Cost per device? $1.50 to $5 depending on how many you pack in. For maximum capacity, use a galvanized steel trash can. $20 at Home Depot, 20-gallon size. Verify it's metal. Magnet test. Place a phone inside, put the lid on, call the phone. Should be unreachable. If not, add aluminum tape around the rim. Organize the interior with cardboard boxes. Load your entire household's backup electronics, laptops, tablets, radios, solar gear, batteries, tools. One can protect 20 to 30 devices. Cost per device, $1 or less. Not portable. But if you're bugging in, this is your vault. The commercial EMP bag industry has spent 2 decades convincing you that DIY solutions are unreliable, that you need lab certification and multi-layer engineering to ensure protection. This is gaslighting. Faraday cages are not complicated. They are not new. They're 1836 physics, and the requirements are simple. Conductive enclosure, continuous coverage, tight seal. You can verify this yourself. You don't need an $8,000 spectrum analyzer. Put your phone in your DIY cage, seal it, and call it. If the call doesn't go through, the cage works. If you want to be thorough, buy a $20 RF bug detector on Amazon. Detects 1 megahertz to 8 gigahertz. Place it inside your cage, seal the cage, and transmit a Wi-Fi signal nearby using your laptop's hotspot. If the detector stays silent, you're shielded. If you're a perfectionist, rent or buy a spectrum analyzer, run the same tests I did, and generate your own attenuation curves. The data will match mine. Chip bags work, foil works, ammo cans work, trash cans work. The science is settled. The only variable is whether you're willing to spend 10 minutes building something yourself, or whether you'd rather pay $50 for someone else to build it and slap a logo on it. The prepper industry operates on a fundamental con. They take public domain knowledge, repackage it with tactical aesthetics and fear-based marketing, and sell it back to you at 2,000% markups. Faraday cages are public domain. The physics is in every undergraduate textbook. The materials are in your kitchen. They're selling you the illusion of expertise, the comfort of a brand name, the idea that preparedness requires expensive gear. It doesn't. It requires understanding. It requires testing. It requires the willingness to build things yourself and verify they work. That's what this is about. Not whether Faraday cages work. They do. Not whether EMP is a threat. It's a low probability threat. But solar storms are real, and the grid is fragile. This is about whether you're going to let an industry exploit your fear and your ignorance, or whether you're going to take back control, build your own protection, and spend the savings on things that actually matter. Food, water, medical supplies, skills, community. When you tear open a $50 EMP bag, you find metallized polyester, the same material that lines a chip bag. When you calculate the skin depth of aluminum at gigahertz frequencies, you find that thickness is irrelevant. When you test a trash can against a $300 Faraday tent, you find identical attenuation. The industry has no rebuttal to this. They can't argue with calibrated data. They can't argue with physics. So they argue with fear. They tell you that DIY is risky, that you can't know for sure, that certification matters. But certification is just a receipt. It proves someone paid a lab $5,000 to run tests. It doesn't prove the product works better than something you built for $5. The tests prove that. And the tests say the chip bag wins. You have a choice. You can keep buying their bags, funding an industry built on markup fraud and threat inflation, or you can walk into your kitchen, grab a chip bag or a roll of foil, and build a Faraday cage in 5 minutes. Test it, verify it works, store your electronics, and, When the grid goes down, if it goes down, you'll have working devices. You'll have radios to communicate, charge controllers to keep your solar panels functional, hard drives with your critical files intact. You'll have done it for the cost of a bag of chips. And you'll have done it because you understood the physics, you ran the tests, and you refused to pay $50 for 50 cents of aluminum. They sold you fear. Then they sold you the solution. But the solution was already in your hand. You just didn't know it yet. Now you do.